Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about IM-1 or Odysseus has landed. So let's dive deep into it. So what exactly is the idea? You must hear this. I'm reasonably sure you have already heard it. NASA's Commercial Lunar Payload Service or CLIPS. So what the hell is CLIPS? Well, CLIPS is the idea that NASA does not want to go broke again. So it's a new way of getting to the moon for cheap. What does cheap here means? Well, think it this way. If a country is backing you, like NASA is getting country level backing, as in 4% of national GDP or national budget, they're going to go YOLO. They're going to build Apollo, they're going to land. But here's the once it comes down, then it's like, yeah, we can't burn money like that. So they're like, okay, let's relax a bit. So at that point in time, they had built shuttle. Now, shuttle was a disaster. Financially speaking, safety wise speaking, it was just bad. Like engineering wise it was good, but it was like bad. So it was really bad. It was like almost costing 1.5 billion, 1 billion to 1.5 billion per launch, same price as basically Saturn V. So they reached a point where they had to cancel it. They could not afford it. Same thing is happening with SLS. They know for a fact that SLS would be the last rocket, because they cannot keep doing like this, where it's like, oh, it's gonna be $500 million, oh yeah, and then it's like, yeah, Congress, can you please give us like 2 billion plus? Yeah, that's not going to happen. So they need to find a way to do it cheaply. Commercial is the cheapest way. How do we know this? Well, $1 billion for shuttle launch. You're like, oh, it can launch. Yes, deal. If you only wanted to send people, you had a shuttle, you had to find something to put inside it. You had to find to use its payload. So it was overbuilt for what it was. And when basically armed forces were like, oh no, we need this payload, we're going to put some stuff into it. They never actually did it, so it backfired. So it was a very interesting history of look into it, like why space shuttle was so stupid. Like even NASA is like, this wants this wants that, they want this, they want this. It's like, you got garbage at the other end. So all they want to do is build the same idea, shuttle service, and then let the commercial company do it. Commercial company will be very refined, very fine-tuned, and the technology is already sorted. It's not unknown technology, it's sorted. So the idea is industry will build shuttle services, same way SpaceX does. SpaceX, let's say they charge $250 million compared to $1 billion. It's much cheaper and it's much quicker. It's like they can launch boom, 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 boom. If they have a huge ass space station, they're like fully loaded. So that's the whole idea. The success they have got with low Earth orbit, they want to extend it to lunar orbit. So basically, take from sea level to yeet it to the moon's surface, and NASA will only build the payload, only build the science of it. So NASA will pay in terms of ride share level. So cost of each mission would be very low, because many times we do get distracted by the fact, oh, this mission, but again, it's never this mission. Like for example, if you go to NASA, it's like, oh, this Ingenuity helicopter. It's never Ingenuity helicopter. It's the whole goddamn pipeline that NASA has to build. Now they can be like, okay, if you want to do something on moon, or maybe in future even Mars, it's like, that's it. That's the only thing we are building. Who can carry us there? That's it. So NASA will be paying ride share level. So for example, this puppy can handle, let's say, 12 slots. NASA will only buy, if they need, they can buy 8. If they need, they can buy a whole 12. If they don't need, they can still buy one only. And they will wait until all the commercial passenger fills it up. Super cheap prices. Should be exponentially cheaper. Let that be very clear. By the time this will get into full pace and they are getting things done, it should be so cheap. It would be like, yeah, it crashed. Who cares? Just launch another one. That's how cheap it should be. And many companies should be providing this regular service. That's the interesting aspect of it. Basically, NASA does not even need to provide radio control to it anymore, meaning Nova controller they have. Like other companies are also working. Let that be very clear. It's not like, oh, only one company is there. Other companies are working. For example, Rocket, SpaceX, Vulcan should also start to grow its own wing, and hopefully Blue Origin also catches a break. So that's the end game of NASA. So it's like, I cannot handle private contractors, reaping our bank account. So let's make everything commercial as possible. That's the whole point. So they need to do a lot of technological testing for Artemis mission. If they directly try to do it themselves, they will go bankrupt before even they had a lunar landing. So what were the launch and communications? Well, launch was done by SpaceX Falcon 9 on 15 February 2024 at 1 a.m. Eastern Standard Time, or 6:05 a.m. Universal Time Coordinate. And this puppy happened. It was very flawless. On 22 February, it reached basically Moon. 2 February 2024, 7 days to reach it. So 7 days is not super fast, as in like the fast would be around 3 days of Saturn class rockets. So it was not slow, nor it was super fast. So it was like mid-ish, so to say, and it did not require a lot of orbit raising maneuvers. So now that's the rocket part sorted, no problem. What about the communication? Right now, deep space network is basically the backbone of the whole planetary communication, but that's not sustainable. Private communication. So they have private lunar data network. That this puppy, basically a complete infrastructure is being built slowly in the background, so they can take over the private load of it. They're like, okay, NASA, deep space network, awesome, you take care of it. If something bad happens to deep space network, we got this. If something bad happens to us, you got us. So a very good way of, you know, distributing the load and increasing the capability without having single point of failure. Thou shall not have single point of failure. Thou shall never be in space shuttle again. Single point of failure. They lost space shuttle and they lost everything. That should not happen. So there's a launch and communication. Both are awesome. Now let's understand this shuttle part of it. That is Nova C lunar lander. So this puppy was the main bus that they were carrying from sea surface to lunar surface. Now it can carry 130 kilograms. Now that number may sound very small. It's like 130 kilograms. I'm like, that's more or less what Electron rocket launches. Here's the deal. You have to understand, whenever you look into NASA's stuff, whatever stuff it may be, you'll be like, okay, or even Chandrayaan 3 mission, when it landed, you will be like, okay, the payload was this huge. But here's the, we are counting the whole payload. If you look into this, like how much is there of actual payload, like actual science instrument, what is the weight of the science instrument? It would be like few kilograms. That's the whole point. From that perspective, it's huge. Oh, you're telling me 130 kilogram for science payload? Shut up, take money. That's the interesting part here. 130, again, this is huge, but this is a whole ass bus that can do everything: navigation, power management, telemetry control, and soft landing. And in principle, let that be very clear, it should be able to vertically take off and land again, meaning inside a day, it should be able to do hops. It's built for that. That's why you may be like, it's a bit too tall. It's designed that way. So full craft is a size of TARDIS, and those who don't know, please Google it. I'm reasonably sure almost all of you know. And how the heck they are running this puppy? Well, they're running it based on helium pressurized, basically pressure fed engines that are VR900. Who came up with that name? And it's running on liquid helium, basically liquid methane, LCH4, and liquid oxygen. So these composite helium tanks, and the inside they have oxygen tank and methane tank. Now here's the deal. That helium, they are double cycling it, meaning that helium is not only pressurizing the main propellant system, it's also acting as a cold gas thrusters. Basically the thrusters that are on top, it's also working, and it has the benefit you no longer have to worry about peroxide contamination. So that's good. So helium, methane, and LOX, everything is cool. Now be mindful, they are also very proud of the fact that they have cryogenic fuel. It does not boil off. Be mindful, they had to put it in a launch pad 7 days just to reach lunar surface, and then they had to stand. And in principle, it has to be designed in such a way that it can do hops, meaning the whole propellant should not boil off. So they have very thorough insulation on it, and that's why you only see basically a helium part on the exposed area. It's designed in such a way that those parts could remain cool and can be actively cooled. And again, whoever is buying payload, they do not have to worry about it. It's like, it's a bus, I'm eating my stuff in the bus. So helium pressurized system, LOX system, and be mindful, this is the world's first methane oxygen system in deep space. Deep space being outside of a geostationary orbit. So they're like, oh, China launched into the orbit. Raptor almost touched orbit. This is like, bruh, come to us. We are on a whole different level. Like, we are 1 light second away from you, bro. So it's a very far away. And everything, the tanks and the structure, they are made out of composite. Again, titanium would have been far more expensive. Aluminum would not have been good enough. So composite it is. That's what they did. And they have 3 solar panels. One side solar panel, second side solar panel, and top solar panel, 3 solar panels. Total power budget should be around 700 watt with batteries. So that means any mission that you are planning into it. Now be mindful, this bus is only designed for 14 days period, as in half month. 1 lunar day. It lands on the moon. It can even hop around, but it can only do it for 1 lunar cycle. It does not have radioactive generators. While it's insulated, it's not so well insulated that it's like, I get this. I think it will still need some radioactive heaters. But let's say they dropped 130 kilograms, 30 kilogram of it. They had a small RTG to it just to keep batteries healthy, temperature healthy, and comms keep working. That can be done, but again, I do expect that to happen in Nova C, D, E, F, and yes, they do have different variants of it. That is much larger unit. Unit is so huge, it's gonna carry a rover on top of it, then drop the rover. So this is the bus that did the whole mission at this point in time. So what were the payload? Yeah, this is where they went a bit comfortable. They were just like letting things go. So NASA has few payloads. I'm not even gonna pronounce it. And be mindful, this company is one of the best when it comes to press kit. Download their press kit. It's awesome. Every single detail that you can ask for is gonna give you orgasm. So it has ROLSES, one payload, LRA, another payload, NDL, another payload, SCALPSS, another payload, LN-1, another payload, RFMG, another payload. Total 6 payload that is from NASA. And it's not from NASA's one branch. They have like one from this branch, one from this branch. Everybody's just going YOLO on it. And that's the whole point. That's the whole point of doing this in commercially, rather than everybody coming to this one building, everybody designing an integrated system. No, this is a bus, yoink on top of it, done. And what about commercial players? Well, they have few commercial players. So you have Columbia Sportswear, like this company. And like, why the heck a sportswear is there? Be mindful. You still need companies to build things for space. Many times we kind of disassociate space technology or weapons technology to like just magic. It's not like that. It's like some basic companies building, so like, you know, some fighter jet parts. That's how it happens. So this company is responsible for making insulation. It needs insulation, best quality insulation, so it can survive rocket firing. Because again, if you're landed on the surface and you fire the rocket, there would be enough back poof, and enough heat, and given the fact that you have cryogenic propellant, that heat flux, if it soaks into your chassis, yeah, it's gonna boil off liquid exponentially faster. You will not last 14-15 days. Again, your propellant won't last. So they needed a way of insulation testing it. Where do you do actual insulation testing? Actually on site, actually on moon. So that's there. Then you have Eagle Cam. Eagle Cam is this puppy. Basically, they're gonna yeet when they are landing. They're gonna yeet this puppy, and this is gonna do fall. Now be mindful, it's lunar fall. It's much slower. That's why you may be like, did they just throw a camera away? Yes and no. Yes, they did throw it. No, it's not Earth, so it's not gonna tweet. It has much slower fall. So it has actual time. And be mindful, they also were testing a new optical technology that should allow cleaning of the surface using electrostatic systems. Benefit of that, if that technology works and works as intended, that will make life much easier on lunar surface, because you will not have to worry about lunar dust. So good technology testing. And then they have Jeff Koons moon phase, this balls basically. So the idea is that's an art installation. It's not scientific, nothing to do with stuff, it's art. And like, people are really paying that much? Yeah. So all those balls are moons in different phases, and each ball is dedicated to a human that is like done something amazing. It's interesting from art's point of view. And again, where is your art installation? On the freaking moon. And yes, there is 3 versions of it. One on the moon, one on the earth, another NFT. Yes, do not ask me why the heck they built NFT for it. So that's there. And International Lunar Observatory, another system, this one, where they are observing, basically, it's a precursor mission, so to say. So Lunar Observatory is there. Galactic Legacy Labs, if I'm not mistaken, this disk is from them, where they have like a Rosetta disk kind of structure. Whole Wikipedia is there. I was talking about this in one of my Future Friday video, that in future, humanity has to store data, archiving data into the moon, because that's the best place we know as of now, where we can store something and it cannot be oops out of existence. People already started working on that. Oh, and then there is basically Lone Star Data Holdings. Like, wait a minute, what is data holding there? Yeah, they are trying to build server on the moon. Not joking, not exaggerating, literally high priority data that must be cold archived reliably, accurately. They are doing it on moon. Of course, this is a testing mission. They put their testing, because I'm reasonably sure right now, because they are not bearing the system, they would have to worry about cosmic rays. So memory, we have memory density, but problem with that memory density is does not work very well with cosmic ray bombardment. So we have to find a way to balance these puppies out. So they're gonna do that. And again, this is just a trial run. They will learn all the data, and then the next version they're gonna scale it up a bit bigger. They're gonna figure out data throughput. That's why the commercial comm network is necessary. You're not gonna get deep space network wholly compromised simply because somebody is transmitting, like, you know, gigabytes of data to the moon. So Lone Star Data Holdings, they are also working on their apps. So this is the core key to this whole point of like financial sustainability to lunar missions. If you can go to the moon, reliably test out every small components, you can test out like lidars, you can test out you know, windows that can clean itself, or spacesuit material that can clean, say insulation material that can keep your habitat in stable, lidar modules, camera modules, and memory like archiving disks. So you have to test out all of those things eventually. And again, the better the commercial things become, the cheaper it becomes for everyone. So there is an exponential benefit to a nation to getting this thing done. And one of my personal favorite, now be mindful, almost all of them have something very interesting. One of the awesome one is this one, that is radio frequency mass gauge system, basically this RFMG. So what it does, because they are talking about cryogenic propellant in huge tanks, they have an issue of sloshing, because you are talking about, unless you are firing the cold gas thruster, you cannot assert motion to it. How would you know how much is there? How would you know how much has boiled off? You don't. So because there is no gravity, so you cannot get it reliably done. So what they are using is radio frequency. They are bouncing radio waves of around let's say 800 megahertz, if I'm not mistaken, to 1.5 gigahertz. So in that zone, they are bouncing signal and it's coming back with a resonance frequency. Based on that, they can give you accuracy of like how much it's filled to 2% plus and minus. And it's absolute. It works in 0G also. It's absolute, meaning if I said it, of course, computer program may have even extra buffer where it's like, you know what, the people who build this instrument, we give you 2% plus and minus. So computer software will be like, let's be conservative, let's make it 3% plus and minus. So, and there is a very good reason for developing this sort of maximum technology. All the older missions, we just went brute force, meaning many times rockets just had way bigger propellant systems, way bigger, because that there was no actual way of knowing how much you have used. So there was always the idea of just pack bit more in. So this will allow far more mass efficient things. And again, is that needed? Not for human missions, because again, in human mission you will always go old school. You're like, bro, I want redundancy with some extra redundancy. So of course this is not a good thing. But for artificial shuttle kind service, if they can trim down mass in that department, that's good. Again, even in this mission, they learned that their helium consumption was a bit much more than they were expecting. So of course, next time they might just scale helium up, or they might fine tune the protocol, or may increase the yield of it. There are many things they will learn. That's the whole point. So commercial system allows so many things to be done in one mission. So what about the landing? Well, they had a oops moment with this. So basically that initial oof was, whenever you see a aircraft, you must see there has a lot of tags: remove before use, remove before flight. Missiles also have that. So same thing was with the lasers. Any lasers that is made by any proper company and has laser that can poof your eyeballs, generally have a very good safety system built into it, especially if you are talking about something like this high grade. So they had apparently a key that was like, you physically have to arm it. You physically have to disarm it, because the idea is it will be disarmed until you are damn sure everybody is fully checked up. It will not be like, oh, static discharge happened, it fired the laser. No. It's like you can plug in the power, it will not fire the laser. You can do all the telemetry testing, it will not fire the laser. Unless you remove the key, it will not fire. Basically that remove before use. So that was not removed. They launched the rocket, it was not in use. They did talk with the company. It's like, can we override it? It's like, if you could override it, won't be safe. So, and again, it was physically designed in such a way that it could not. That's a very good safety system, but it was like, oops. So they had, dead LiDAR while they were going to the moon. So that was like, yeah, the mission has scrapped. So they figured out something very interesting. Same way a Japanese landing was like one nozzle just yeeted out of there. Here they just became blinded while they were trying to land. So they did something very interesting. One of the payload was a LiDAR system itself from NASA. And again, NASA was slowly pushing it to the readiness level of actually just use the damn thing. It's like apparently they have 7 levels, they were level of 5. So thing was built, thing was thoroughly tested, but it was like, we really need to keep testing it more and more. So here's the deal. What you have level 5 technology, you want level 9, you have level 5, you have 0. Because you did not remove the key. So they were like, okay, let's just patch this puppy up. So they made a software patch and it worked. They somehow got all this thing done in 1 hour. Everybody is shocked by that. Like, how quickly can you do that? It's like 1 hour it worked, and it did do the soft landing. However, the issue was, while it was landing very perfectly, it messed up the lateral velocity, meaning the things that is coming like down like this, the downward velocity, awesome. It's like, I'm exactly how I should be. However, it's because again, you're talking from orbital velocity, is supposed to be like this, right? But here's this axis motion was a bit faster than they were anticipating. So it did land, but it was like going like a jogging speed, so to say. So it tipped over. So this happened. So one leg hit something and it fell over, and based on the telemetry data, it fell over on something that was like almost at the same size. They think it's on a boulder or something like that. So it happened. Now here's the deal. Didn't it destroy the system? Well, thankfully, Moon has lower gravity. That's why this puppy is fully working. Now, Can we consider this mission a success? Short answer, if you consider a Japanese mission a success, this was a success. Now how much? Let's compare from 0 to 100. How much this tipping over harms them? Very little. Very little. They were very glad that most of the solar panels are working. That's why you keep hearing that, like, yo, solar panels are working. They're getting charged. So that biggest issue solved. Second, because it was a very soft follower, it did not damage or destroy it. All the telemetry data is showing that we good, everything is intact. What about all the payload? Can they do their work? Like, most of them can. Most of them can work without any issue. And all the passive things like arts installation, yeah, it does not need to see the sun. So everything is fine. Everything is dandy. Of course, the biggest issue, the reason we do not have everything right now sorted when I'm making this video is that antenna is facing downward direction. So the algorithm, people who built the algorithm, they built it in such a way where it will, if it fails to reach stable ping with the earth, it will keep switching and keep cycling all the radios, basically all direction, omnidirectional kind of cycling. The cycling is working. That's how they know that this is working. This is alive and sending telemetry data, but it's not locking on. Basically, it's latched into a stupid position. They have to unlatch it. They could be doing that. And by the time I'm talking to you, there is a very good chance that patch may be uploaded right now. So by the time you are watching this video, it should have been sorted. So this is a good mission, and that was the whole point of commercial system. Peregrine just went boom, and they're like, no problem, we got a second one. It's landed, it worked, and all the team who worked in that NASA's LiDAR system, they are orgasming because they're like, bro, we jumped from level 6, if I'm not mistaken, level 6 readiness to level 9 directly. Like, we done, bro. Like, we actually landed based on it. No more testing need. Of course, they will test a bit more, but you get the point. Like, from a readiness point of view, it's as ready as it can be. So they are happy. And I would like you to tell me which movie this is from. I repeat, the first commercial lander has landed on the moon, and it is American. So commercial part matters here. Let that be very clear. Landing part is not that whoa, but the commercial part is whoa. Because be mindful, we literally went from space shuttle launching 2 times a year to SpaceX launching astronauts to ISS, if they want to, 2 times a month. So that's why the commercial part matters more than the technology, more than everything. The fact that things can come around, the fact that government bureaucracy can be cut through, the fact that commercial company can work competently enough where they can have a system that can actually land on the goddamn moon, that is like, damn. And be mindful, there is a third one, ready to go. It will be launched, if I'm not mistaken, in October. Oh, one after that is already ready. That will be carrying basically NASA's rover for the moon, huge rover on the moon. So that's the whole point, the commercial speed and velocity and how quickly they're going to get technology improvements because of that. That's the, like, golden goose, so to say. So landing was interesting, let's just put it that way. Oh, I have linked the videos down below. So this was my presentation on basically lunar landing season that we are dealing with. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.